Alright, welcome to the Algebra 1 video on equivalent algebraic expressions, which is just a fancy way of saying or asking the question, is one expression equal to another expression? So comparing two things and then determining whether or not, even though they are written differently and may look differently, whether mathematically they represent the same quantity. So we're going to go over a bunch of rules first, most of which you already know and have been using, but this is a nice summary and review. And then we'll see how to apply those in order to compare if two expressions are equivalent to see if you're solving problems correctly. So this is going to be mostly review, but I think it's really important to step back and think about all the things you've learned so far in the first couple of months and make sure that everything is what you think it is. So we'll start off with the distributive property. You guys always learn this, or in class I always, let me get back to my brush. I always go like, draw the little rainbows or whatever you want to call it. So whatever number is in front of the parentheses, you multiply into each thing inside the parentheses. And by each thing inside the parentheses, I mean each term separated by a plus or minus. So this caused some confusion, I know, in the past. If you have something like 6 parentheses 3x, close parentheses, the 3x is all one piece in terms of distributing. So you do not distribute the 6 to the 3 and the 6 to the x. 3 times x is multiplication, and 6 times whatever's inside is multiplication. So we just have all multiplication. So this right here would be 18x. Whereas if you had 6 times 3 plus x, okay, now these are two different terms. This is a binomial. It's one thing plus another thing. Here's where you're going to distribute into both of them separately, and you would have 18, 6 times 3, plus 6 times x is just 6x. You can't combine them. So very big difference. So make sure that you're being careful when you distribute. If there's parentheses with things added or subtracted inside, you distribute in whatever's on the outside once to each term inside. But if everything inside is just multiplied or divided, you only distribute into the numerator. That's another good question. What if you have 6 into 3 over x? Okay. This is only being multiplied. So this 3 right here is being divided by x, and the 6 is being multiplied by this whole product. So you could think of it like that. It definitely does not multiply into the denominator. This 6 is only being multiplied in the numerator. So the answer is 18 over x. If you don't like that, you can always imagine this as a 6 over 1. So visualize that. Let me do one final example. What if you have 6 into 3 over x plus, I don't know, x over 3, something crazy, right? Now you're going to distribute this in here, and you're going to distribute this in here, but when you distribute it in, the 6 is only multiplying the numerator. So in the first one, the 6 is multiplying by the 3, which will give you 18 over x. Again, this x in the denominator stays in the denominator. Okay, plus, because of the plus sign. Now you can distribute the 6 over here to this x. 6 times x is 6x. Divided by the 3 that was in the denominator stays in the denominator. I guess I needed to have a closing parenthesis there, I apologize. But when you distribute the 6, you distribute it in twice because these two terms are separated by a plus sign. But when you distribute it in, it only goes to the numerator. It does not go to the denominator. So I hope these are good examples of distribution, when to do it, when not to do it, and how to do it, just to help you remember, keep track of those kind of things. Okay, the next one is the commutative property of addition. This just says that if you add two things, the order doesn't matter. A plus b is exactly the same as b plus a. And then here's an example. 3 plus 4 equals 4 plus 3. So when you're adding things, you can change the order. You just have to be really careful about adding or subtracting minus signs. So let me clear space here. I keep forgetting. Sorry. Bear with me. Okay, commutative property. If you're keeping track of minus signs, you might have something like this. 5 plus 2 equals 2 plus 5. Great. Those are both equal, in fact, to 7. If you have something like negative 5 plus 2, okay, when you do commutative property, you change the order of those two things. The negative here is attached to the 5. So this is the same as 2 plus negative 5. So you see this this negative 5 is one thing, and this 2 is one thing. So if you change the order, the negative has to go with it. It's not the same as keeping the negative there and saying negative 2 plus 5. Okay, that is different. Both of these are what? Negative 5 plus 2 is negative 3. So when you're adding and you change the order or group them, the negative sign has to go with whatever number it is. So if you're rearranging numbers in an expression, like maybe you have x squared minus 5 plus 3x, you can rewrite that as x squared plus 3x minus 5, right? You're changing the order of these two terms. You're swapping them, which is totally okay, obviously. That's what this whole property is telling you. You can change the order of these two terms that are added, but the negative sign goes with the number. That's really, really important. All right, the next one, commutative property of multiplication. So just like commutative property of addition, you can multiply two things in any order, and it does not change the result. So a times b is equal to b times a. That's really, really useful. Oops. And we're going to do a couple examples here. So 3 times 5. Let's just look at some numbers. That's the same as 5 times 3, which is equal to 15. Great. Okay, now it's a lot more complicated, not a lot more, but it's a little more complicated when you have variables. What's x times 4? Okay, that's just 4x. And you can write it either way. This is actually the preferred way to write it. You put the number in front and then the variable. But x times 4 is exactly the same as 4 times x. So when you see it either way, you should recognize immediately that that's the same thing. Okay, well, what if you have something more complicated? 3 times x times 6. Okay, you can write this again. The rule here is a times b equals b times a, but it extends to even more things than just 2. So if you have 3 things multiplied together, 1, 2, 3, you can put all the numbers together. So this is the same as 3 times 6 times x, which is then 18x. Okay, so when you're multiplying, the order doesn't matter. So you can pick out all the numbers, multiply them together, and put that in the front. And then if you have more than one variable, you can do that as well. Okay, what if you have all variables? X squared times y to the third times x to the negative third times y times x. Okay, the order of all of these can be interchanged. So technically, visually you might think, okay, I'm going to put my x's first. So I'm going to write x squared, then I'm going to write x to the negative third, then I'm going to write x. So that guy's taken care of, that guy's taken care of, and that guy's taken care of. Then I'm going to write times y to the third times y. So that guy's taken care of, and that guy's taken care of. It's kind of nice when you're rewriting an expression with a lot of terms to cross them out as you go, or underline them as you go, or circle them as you go. Something to allow yourself to prevent accidentally double counting something. So if you cross them out or circle them, you won't use them up twice. So now that we have all these guys in the right order, it's very simple to multiply all the x's together. Okay, when you multiply two things with the same base, you know the rule by now. You should add the exponent, and this little guy here, he has no exponent written, so it's automatically a 1. If it's not written, it's automatically a 1. 2 minus 3 plus 1 is x to the 0. I'll write that in just to be showing my work, x to the 0, times y to the third times y is y to the fourth. Remember, the exponent just tells you how many times you're multiplying something. So if you already have y cubed and you multiply it one more time, you're multiplying it one more time, so the number in the exponent has to go up by 1. Okay? X to the 0 is just 1, because anything to the 0 is 1, so your final answer would be y to the fourth. So multiplying, you can change the order, and a lot of times you change the order without actually writing it down differently. You look at this, and in your head you're like, okay, I'm going to take this one, and I'm going to multiply it by this one, and I'm going to multiply it by this one. So you don't have to rewrite it necessarily in the right order to multiply. You can just pick out the terms that you want to multiply those first, and then multiply the rest later. Alright, let's clear some space. Next one, associative property of addition. Associative property of addition says that if you're adding a whole sequence of many, many numbers, you can add them in any order you want. Now this gets a little tricky when you have subtraction, which is the same as adding a negative, so I want to do some examples to help illustrate what I mean. But let's start with their example. This one's a real simple one when it's all positive numbers. If you have 2 plus parentheses 1.5 plus 3, you could first add the 1.5 and the 3, and you could obviously get 4.5, and then you could add 2 plus 4.5. That's what you should do according to PEMDAS, and that's going to be 6.5. On this side, you have 2 plus 1.5, which is 3.5, plus 3, which is also 6.5. So you can see that when it's all addition, changing the order doesn't matter. I think that's pretty clear and something you guys already know. What I want to point out is when you have adding a negative. So what if you have 3 minus 6 plus 4, and you put the parentheses right there? Is that equal to 3 minus 6 plus 4? And I'm going to put a question mark here, and we're going to figure out, is that equal? Okay. In this one, what should you do first? 6 plus 4 is 10, so you have 3 minus 10, which is negative 7. Okay. On this side, you should do the subtraction first. 3 minus 6, that's negative 3, plus 4, that's 1. So these two things are not equal. Okay. What did we do wrong? What was the problem? The problem is this minus sign right here is outside of parentheses, and so you could visualize this one here as 3 minus 1 times 6 plus 4, and when you have a negative outside of parentheses, well, whatever is outside the parentheses gets distributed in. But if it's a 1, distributing in a 1 doesn't matter, right? But if it's negative, distributing in a negative changes it. So this side is actually 3 minus 6 minus 4. And so it's not exactly the same as this side, and hence it doesn't work. Let me make some space, and I'll do another example so that it's painfully clear. Okay, so let's do another one. 2x plus 4 minus x, and put parentheses right there and right there. 2x plus 4 minus x. So in this case, can you combine 4 minus x? No, you can't. Here, can you combine 2x plus 4? No, you can't. So in this case, we just have to trust that the rule works and say that it doesn't matter what we do here. In fact, we can go back a rule and use the commutative property of addition to change the order of some of these things. Maybe you want to change the order of these two things. That's okay. So then you'd have 2x plus negative x plus 4. But this one is hard to describe what to do because, I mean, there's nothing to do in this one. These parentheses don't do anything. In fact, what I would argue, instead of saying that this is the same as this with these parentheses here, is the same as having no parentheses at all, right? Adding in parentheses to two things that are added together doesn't change the order of operations unless there's a minus sign in front, but we just showed you that's a different case. So I would just get rid of the parentheses completely, and I would go 2x plus 4 minus x, and then you can change the order, which means you can add in any order you want. So you can add that, and you can add that. But you have to take into consideration that this one here, every number includes the sign in front of it. So this is 2x plus a negative x, or 2x minus x, which is just x, and then this is plus 4. And of course on this side you do the same thing. Get rid of the parentheses because they don't do anything, and then combine like terms. So let me reiterate that, really important. Parentheses don't matter if everything is added or subtracted, and then whatever is in front of the parentheses is positive. If the thing in front of the parentheses is negative, though, then that parentheses is really, really important because that's multiplying by -1, and that negative sign needs to be distributed inside. So let me make a final little notice here. highlighting the difference. So if you have 3 minus parentheses x plus 1, the way to do this is distribute the negative 1. So this minus sign right here distributes into both of these, and that's how you clear the parentheses. Alternatively, if you had 3 plus parentheses x plus 1, just remove parentheses for free. There's nothing you need to do, because what would you be distributing? You could think of it as there's like this 1 right here, and you're distributing a positive 1, but distributing a positive 1 doesn't change anything. Multiplying by 1 won't change the numbers, whereas here multiplying by negative 1 will change the numbers. So, moral of the story, if your parentheses have negative in front of them, distribute it in. If they don't, then the parentheses don't matter. Finally, we'll go through this one more quickly. Associative property of multiplication. When you have 3 or more things multiplied together, the order does not matter. I think saying that you can flip the order of them is just as helpful as saying the order that you multiply them doesn't matter. So I'm not going to do more examples of that, but it's useful to know, and I'm sure you've already done it numerous times. Alright, so all of these that we've just talked about are ways to simplify an expression. And I know I spent a good amount of time talking about the difference between simplifying an expression and solving an equation, right? So none of these follow the golden rule. It's not like you did the same thing on the left as you did on the right. All of these things that we've just gone through are just taking some piece and modifying it some way, combining like terms, spreading it out with distribution, collapsing it down by adding or subtracting numbers together, or multiplying 2 numbers together to get something simpler. So all of these are simplifying expressions. Okay, there's a different type of thing that you can do to 2 sides of an equation, and that's the golden rule. And those properties here, these properties allow you to solve an equation. So you're going to be doing something to one side of the equation, and you're going to be doing something equivalent to the other side of the equation. And these are the 4 things that we've covered in quite a bit of detail. One is, if you have some equality, A equals B, that just means something on this side of your equation and something on this side of your equation. It could be really big, complicated things here on the left and here on the right. If you add the same number C to both sides, so aka plus C plus C, so if you add C to both sides, the new equation that you get, which is going to be A plus C equals B plus C, this equation is also true. So if this was true, then this is true. But this side of the equation is no longer equal, or is not equal to what it was before. So you're changing this side of the equation, but you're also changing this one by the same amount. So this is often called the balancing method. So these are not equivalent expressions. These are equivalent expressions. So this one is equivalent to this one, if this one is equivalent to this one. But again, these are not, because you've added something to it, which now makes it bigger. Okay. You can also subtract from both sides. Okay, you already know that. You can multiply both sides by the same number. You already know that. And you can divide both sides by the same number as long as you don't divide by 0. So all 4 of these properties we've practiced quite a bit. So I think we're good to move down a little bit and compare and contrast a little bit more the difference between, or review, the difference between solving an equation and simplifying an expression. Okay, so I've pre-typed in this stuff and color-coded it for you as well. Simplifying an expression, you'll start off with only one side of the equation. So you might have something like this: 3x parentheses 6x minus 4 equals. And it says simplify this expression, or distribute, or multiply these polynomials, something like that, where you're only given one side of an equation and the other side is this big blank, and you're supposed to fill it in, right? So you solve this by distributing, okay, and you get 3x times 6x. 3 times 6 is 18. X times x is x squared. We're professionals now with exponents. And 3x times negative 4 is negative 12x, okay? So this right here and this right here, these two are equivalent expressions. So the answer, whatever you're getting over here, what we're saying is your answer is a simplified version of whatever your starting problem was. And these two things are equivalent expressions. This should be equal to this. Hence the equal sign. That's what equal sign means. It means the two things on the left and the right are equivalent algebraic expressions. The way that you simplify an expression is by following PEMDAS. You won't be adding 5 to both sides because you don't really have this other side here. Where's my mouse? You don't really have the other side here to add to. You're creating that side by following PEMDAS. Okay. Completely contrasted to that is solving equations. When you're solving an equation, you already have both sides of the equation, and you're applying some change simultaneously to both sides, like add 5, divide by 2, whatever change you're doing, you're applying it to both sides at the same time. And so the answer that you get is going to just be a rearrangement of all the parts that were in your original problem. So let me give an example here. Say you have 2x plus 3 equals 11. Okay. The first thing you do is you subtract 3 from both sides, and you get 2x equals 8, right? So 2x equals 8. 2x is equivalent to 8 if 2x plus 3 is equivalent to 11. Okay, of course you divide by 2, and your answer is x equals 4. Okay, so x is equal to 4 if 2x plus 3 is equal to 11. If your starting off equation wasn't right, maybe you had a typo or you miswrote the numbers. So if your starting equation is not true, then your answer will not be true. But as long as your starting equation, this expression 2x plus 3, is equivalent to this expression 11, then your answer, x, is going to be equivalent to 4. So this may seem really stupid. You're like, I already know how to solve these problems. Why do I have to go over this? And all I can say is, I hope you're already an expert at this, and if so, fantastic. And this is just a way of learning the vocabulary and the way that we talk about it. So calling them equivalent algebraic expressions. So this is just a rearrangement of this. Okay, we're almost done actually. Let's just zoom over and do some practice problems, which I've got over here for us, and then we'll be done. Good enough. So he says here are 15 equations. They represent only 4 different lines. So our task is going to be to figure out which A, B, C, all the way through O, which of these fall into line 1, which of them fall into line 2, which one of them fall into line 3, which one of them fall into line 4. And the way that we're going to do that is by simplifying each one and then comparing them. So you can see most of them are already solved for y, which means y equals and then some stuff. So if we want to compare 2 of them, okay, if we have y equals some stuff and then we have y equals some stuff, we can see if those 2 are equivalent. So let's look here at A. Okay, we have y equals. Now this 2 is outside the parentheses, so I might want to distribute that in. 2 times x is 2x minus, okay, what's 2 times 2.5? That's going to be 5. Okay, so y equals 2x minus 5 is equivalent to my starting off one here for A. Cool. Now let's look at B. Y equals, okay, this 2 is going to distribute in, and this 18 is here. Now, I could write these in either order I want. I could do this part first, and then add on 18 at the end, because I can use the commutative property of addition to change that order. So that our x's come first, let's multiply the 2 in. So 2x is 2x. 2 times negative 8 is negative 16. And now I can do this plus 18. How do I know it's positive 18 and not negative 18? If a number doesn't have any sign written, it's automatically positive. Okay, and now I can combine like terms. 2x, negative 16 plus 18 is plus 2. Okay, this one here is not equivalent to this one here, so these must be from 2 different lines. Let's keep going. Here's C. I'm going to distribute this in here, and I'm going to distribute this in here. But what I'm distributing, notice, what I'm distributing is a negative 6. So I have negative 6x when I distribute the negative 6 into the x, minus 8 times 6 is minus 48. And then I have this original 52 plus 52. So that's giving me negative 6x. Negative 48 plus 52 is positive 4. So you guys also want to keep practicing your simple multiplication and simple addition of numbers that are relatively close to each other. Good practice. Okay, how about D? Y equals, distribute in here, distribute in here.
So right here I get 2x plus 2 times 4 is 8. 2x plus 8. And now I'm going to subtract 6 minus 6. So this is 2x plus 2 because 8 minus 6 is 2. So I found two that are equivalent. Okay? Because they both simplified to be 2x plus 2, b and d must have been equivalent algebraic expressions. So this starting off equation, y equals 18 plus 2 parentheses x minus 8, is exactly equivalent to d, right here, y equals negative 6 plus 2 parentheses x plus 4. So even though they look very different, they are equivalent expressions. And that's useful to find. So I'm not going to keep going through all the rest of these. If you want it, it's a lot of good practice on distributing and combining and adding like terms and then making comparisons. But I'll stop right here and just be aware that you want to just become really, really good at following PEMDAS to simplify expressions and become really, really good at following the golden rule to manipulate two sides of an equation at the same time and be able to make valid comparisons if two things are the same or if they are different. Alrighty, hope you enjoy the homework.